Okay, let's start. Hey everyone, this is Charlie. I'm the CEO and co-founder of XCamp. Today, we have our USACO December bronze live session. We have Weimin here. He will explain the three problems to us. Weimin is a long-time XCamp student. He joined the XCamp class from the beginning level. This year, he joined the USACO finalist, attended the US camp in May. Also, we just heard the good news. He was accepted to MIT as a EA. So yeah, congratulations, Weimin. We are so happy to have you here. So I will turn the screen to you. Please go ahead and explain the problems. Yeah.
Okay. So I guess we can start with the first problem, which so the first problem is Farmer John has cows that have heights A of 1 through N, and each of them is trying to and there's candy canes of heights H of 1 through M that the cows are trying to eat. And the question is after each time when a cow of height uh, A of I tries to eat a candy cane of height uh, H of I, it will eat as much of the candy cane as it can reach with uh with A of I, and then it will increase its own height by A of I. Or by it will increase its own height by the amount of candy cane that it just ate. And the question is, after processing all of each of the cows will go in order of 1 to N to eat the candy canes. And the question is, at the very end, what is the height of each of the individual cows? So first, I guess we can use an O of N times M simulation to find the answer. And the way this works is we can use a for loop to simulate um, what each cow does to a certain candy cane. This will take O of N time per candy cane, and there's a total of M candy canes. But in the original problem, N and M are both 10 to the fifth. So this is too slow to pass the full solution. But to pass this problem, we can add a optimization that we break out of our for loop if the amount of candy cane eaten, or if there's no if there's the amount of candy cane left is 0. Uh, and the way this works is that since every single time when if we only consider the first cow and he has a height of let's say A of 1, and if we consider what happens to this first cow after he sees some candy cane of say height H, the first cow will either eat the entirety of the candy cane if H is less than or equal to A of 1, or it'll eat part of the first candy cane and double its height. So if H is greater than or equal to, or strictly greater than A of 1, um, then it'll double its height. Or yeah. I don't know if there's a or because since the USACO contest window just ended, I don't know if there's any public like sources of the problems. I don't have any saved copies of the problem statements themselves. Uh, So, why this fact that the first cow will double its height matters is that if we can the first cow can't double its height that many times. And since we know that all of the input values of h of I and a of I are less than or equal to 10 to the ninth in the original problem, after the cow doubles around 30 times or increases its height by 2 to the power of 30, the first cow will be guaranteed to eat all the candy canes immediately. So what this means is that at most 30 or log h of I possible candy canes will make it past the first cow. And this altogether leaves us with a final complexity of O of n log h of I plus m. And the final code is just the O of n times m brute force with an extra optimization added to break out of the for loop if the total amount of candy cane is equal to the candy cane's height. So like if there's no more of the candy cane left. Uh, that's it for the first problem. There's any questions or okay, if not, then I'll go on to the second question. So the second question is you're given a binary string of some length that's either or that means that's all zeros or ones. And what the binary strings represent is they represent cows that are sick. And what happens is that if a cow is sick, over the course of one night, it'll spread its sickness to the two cows that are adjacent to it. So, for instance, if the cow on the edge is sick, it will lead to it infecting the next cow over. But if, say, a cow in the center is sick, um, it will infect the two cows next to it. And the question is, given the initial string of length n, where n is less than or equal to 10 to the power of 5, I think, find the minimum number of cows that could have been sick initially to have arrived at this pattern, to arrive at this binary string of sick and unsick cows after after some amount of after like some number of days. So so the way to approach this problem is to first determine the maximum number of days that could have passed since the initial position, since the initial time and this current string. And then after finding the maximum number of days that could have passed, we can then solve for the minimum number of cows that uh okay, thanks. It's 3 times 10 to the power of 5. We can then solve for the minimum number of cows that would have been sick initially. So to find the maximum number of days, we can consider each like clump of sick cows individually. And then so we define a clump as a consecutive set of sick cows. And clumps that are on the edge behave differently from clumps that are in the clumps that are in the middle. So if we consider a clump on the very edge, let's say the one here where it's 1, 1, and then there's like a 0 here. And we need to find the minimum number of cows that, or the maximum number of days that could have went by for this clump to happen. Say the clump is of length x, then the minimum number of days that would have had to pass is x minus 1. And then So this is if it's on the very edge. And this is because we can put one sick cow at the we can put one sick cow at the very edge initially, and then over time you'll continue to get the next cow over sick. And this will take a total of x minus 1 days. Then if we consider the cow in the if we consider the cows in the center, like this cow here with 2 zeros on the sides, then the maximum number of days, if the length is x, then the maximum number of days is equal to x minus 1 divided by 2, and then round it down. So yeah, so if we think about a cow, if we think about a clump that has an odd size, let's say that it's like in this case it's size 3. What would have had to happen is we have to have a cow that's initially sick in the middle here. And then over time it continues to spread to the cows that are next to it until eventually it covers the entire length of the clump. And the number of days that this takes is equal to x minus 1 divided by 2. So for instance, in the case of where x is equal to 3, this would take 1 night. But then if we consider the case where x is even, or the length of the clump is even, then let's say it looks like this. Then the initial configuration has to have 2 sick cows at the very center. Otherwise, the sick cows would spread unevenly. So over time, it will look like this. Oops. So if the size length is x, then it will end up being equal to x minus 1 divided by 2 rounded down. So in the case of 4, for instance, it will be equal to 3 over 2, which when rounded down is 1. And this is true because we can't just have one cow at the very center, since if we had one cow, it would spread out in a length that's always odd, and it can't make the even length that is required here. So with this in mind, we can solve for the maximum number of nights that would have had to have went by before we before we get all the cows sick. Then after we know that, we can determine the minimum number of cows that are needed. And how this works is we can then consider each clump again. Say here, so here above, we can determine that the maximum number of days that would have went by is 1. And we can, for each clump, we think about placing cows optimally such that after that 1 night, all of the cows within that clump will be sick, and none of the cows outside that clump will be sick. And how this works is we have x divided by 2 times night plus 1. And then this has to be sealed, or this has to be rounded up. Since, for instance, if we consider a clump of length 4, and we know that it only took, or let's first go to a sample. If we consider a clump of length 2, and there's one cow that was sick initially, then what we have is 2 divided by 2 times 1 plus 1, which after being rounded up is equal to 1. And this corresponds to placing 1 cow here. And then if we have clump of size 3, this corresponds to 3 divided by 2 times 1 plus 1, which is also equal to 1, and this corresponds to placing a cow here. And if we made the clump sizes a little bit bigger, let's say a clump of size 4, this will be 4 divided by, which when rounded up is equal to 2, and this corresponds to placing a cow here and a cow here. And this is the minimum number of cows that it would take to get the entire string sick. And the final complexity will end up being O of n, since there can't be more than n clumps at the end of the day. And then as a note, the idea of finding the maximum number of nights and then the minimum number of cows is somewhat straightforward, but it's easy to mess up on some of the implementation details. So be careful about that, especially the cases, quite literally edge cases, where it's the cows that are on the very edge. And there's also a case where they're all zeros, and you have to be careful not to accidentally runtime error or something, since there aren't any clumps at all. So that's it for the second problem. Does anyone have any questions or?
Yeah, wait, so how did you what was like the intuitive like thought process to get x over 2 times 9 plus 1?
Oh, sure. If you let me erase a little bit. If we think about placing a cow in the center, sorry, my pen's struggling. And then over the course of some number of days, the cows will continue to grow outwards, or like how this cow makes the cows next to it sick continues to grow outwards. And if we don't want these, and if we want to minimize the total number of cows, we want to try to have these cows trying to make other cows sick not overlap when possible. Since, for instance, if we were to put another sick cow here initially, we can see that they'll overlap and they'll both get this cow sick. They'll get this cow sick twice. But instead, if we had placed this cow out here, this will get more cows sick as they don't overlap. So this is why. So if we know that it'll take nights, right? The like, let's say area of influence of some cow is equal to 2 times nights plus 1. And since we want to space out the cows whenever possible, it'll be the same as just dividing the clump length by these cows, by the number of intervals that it takes. I hope that helped answer your question.
Oh, yeah. That makes sense. Wait, so but so when you do the division, right, it always gives you one number, but how do you know like because the different positions for every infected cow? Because wouldn't that only give you like one number?
Oh, well, oh, it's like, uh, do you mean like, for instance, let me erase a little bit. Like you're asking how I would know the answers individually for this clump of size 2 and this clump of size 3 if I'm just dividing to get one number, or
Yeah, wait, so like would that one number like what would that one number be like the position where the infected cows are?
Wait, so what's the one number that you're referring
Like
to?
the x over 2 times 9 plus 1.
Oh, I see. This course, this is the minimum number of cows needed to infect a clump of size 10.
Oh, okay, yeah. Okay, yeah. That makes sense.
Okay.
All right, yeah. Thank you.
Okay. So then, are there any other questions? If not, then I'll move on to the third problem. So,
Hi, Wei there's a kind of a question in the chat. Would you please check they are all answered?
sure. Yeah, so for the for like the first question from Fred, I don't know if there's any problem descriptions that are in a written format right now. At least I couldn't find any. As for William's question about for the first problem, what might cause a TLE, I think it's just if your code has the right complexity, it might be something like input, but otherwise you have to make sure to break out of the for loop immediately after immediately after you realize that you've eaten the entirety of the candy cane. Otherwise, the optimization wouldn't work, and you'll end up with a solution that's too slow. Okay, so then for the third question is you have a bunch of it's asparagus. That's what it was. I thought they were trees, but it's probably the same thing. Um, so you have a bunch of asparagus. And for each asparagus, you know its initial height, which is h of I. It's like asparagus I. You know its initial height. You know the rate at which it grows, which is over the course of one day, it'll increase its height by a of I. And then you know what Farmer John wants for this asparagus, or I'll call them trees from now on. You know what Farmer John wants for this tree at the very end when he stops. And what he wants is for there to be exactly TI trees that are taller than it. So you're given H, A, and T. And you're asked to determine the minimum time at which all the trees will fulfill Farmer John's conditions given in T of I. And also, or alternatively, if there's no such times that it's ever possible, report that this never happens. So then for uh for uh for Grayson, I'm sorry if I pronounced that wrong. Um,
Yeah.
I I'll get to that, or like I covered that just now. I don't know if I might go over like I can go over it again later, or you can go to the YouTube live stream and wind back a little bit. Since I just covered the part about where there's something sick at the beginning or the end. I hope.
Okay, thank you.
Okay. So then back to the third problem is we can first notice that if we sort the trees by the values of T of I as like they go from 0 to n minus 1, we can know the final order of the trees, or the final order of the trees in height from greatest to least. Since the tallest tree will have 0 trees greater than it, and like the second tallest tree will have 1 tree greater than it, and so on. And so after sorting them by T of I, we can determine the final ordering of the trees of heights from greatest to least. Okay, so then if we think about so the question got turned in gets changed to you're given an initial array of h of I, and they're now reordered by T of I. They're all like sorted in order of T of I. And after one day, the position h of I will increase by a of I. And you want to determine the minimum time at which h of I is now sorted in increasing order, or sorted in decreasing order. So it's just a reframing of the question, but now we don't have to deal with the T of I array, since we've already sorted h of I to account for that. So then we think about what does it mean for an array to be sorted, right? If we consider some array, let's call it x. X will be sorted in decreasing order if and only if for each x of I minus 1, it's greater than x of I. So only in this situation can the array be sorted in increasing order. And we can use this fact to our advantage for the trees. As what we can do is we can consider, actually, let me keep this. We can consider a tree I minus 1 and tree I. I don't know how it can affect the caption language. Sorry. So if you consider trees I minus 1 and tree I, we can use this fact to determine, like, to help narrow down the window of time. So what we're going to do is we're going to maintain two numbers. Let's call one of them mn for minimum and one of them mx. And the way it works is we're going to use mn to maintain the minimum time at which the trees could possibly all be sorted in decreasing order. And we use mx to maintain the maximum time, the maximum possible time at which all the trees could possibly be sorted in decreasing order. And of course, these don't necessarily, it's like what we do is we'll continue to either increase mn or decrease mx until eventually we end up with a final window of time at which the trees will be sorted in decreasing order. And if at any time mx ends up less than mn, then that means that no solution can exist, since we can't have the maximum time be less than the minimum time. So how this works is, so let's go back to considering two trees, I minus 1 and I. And so let's think about it this way. So if we know that tree I minus 1 grows slower than tree of I, this is what the A value denotes, right? If we know that tree of I minus 1 grows slower than A of I, then at some point, tree I will grow taller than tree of I minus 1. And there's no possible time at which tree I minus 1 could possibly catch up again. So there will exist some time such that tree I will be taller, and it will never be caught up to again. And what this means is that the moment tree A of I grows taller than tree tree of I minus 1, then after that it's impossible for us to have all the trees sorted in decreasing order, since we know that at this point h of I will have to be or h of I minus 1 will have to be less than h of I, but we need h of I minus 1 to be greater than h of I. So after this point in time, it's impossible for the trees to be sorted in decreasing order. So if we can determine this time, we can use it to update our value of mx. And then as for determining this time, we'll get to that later. So, and then in a similar logic, if a of I minus 1 is greater than a of I, there will exist some point t such that before point t, tree of the I minus 1 tree will be shorter than the tree of the ith tree. And after this time, it will have caught up. And since it grows at a faster rate, it won't be passed again. Of course, this time may not necessarily exist. It might be possible that at time 0, the I minus 1 tree is already taller. But if that value is positive, then that means that the answer cannot be lower than this time. Since if it's lower than this time, then we know that h of I minus 1 is still smaller than h of I. So we can use this to update mn. And then as we're calculating that, I'll get to that later. So yeah, so let me rewrite. So then the final case is when the I minus 1th tree and the ith tree grow at the same rate. So in this case, we only care about the initial heights of these two trees. So if the I minus 1th tree has height less than or equal to the ith tree, then that means it will never be strictly taller. Since they both grow at the same rate, the tree on the left will never have a chance to catch up. But if it starts off taller initially, then it will always be taller. So in this case, we can compare the initial heights to determine whether or not it's possible. Oops. And then, so after we loop over all of these pairs of adjacent trees, we'll end up with a final value of mn and mx. And we can if mn is less than or equal to mx, then the answer is just mn, since that's the minimum time at which it's possible. But otherwise, the answer has to be -1. Since there's no possible time at which all the conditions will be fulfilled. The answer is -1. So then as for actually calculating the values, let me erase some stuff. I think I'll just clear it. So if we have so a of I minus 1 is less than or equal to a of I, and we need to find the maximum time at which it's still valid. And then so the no, I mean, no, oh yeah, we wanted to find the maximum time. Actually, I should start with this case since this would be easier. So if we have a of I minus 1 is greater than a of I, we need to update the minimum time. So how this works is we have so h of I minus 1 plus t as in the concept as in time, not taller. A of I minus 1. So it's like this, and we can use some algebra to arrive at the answer. Okay, I'll replace t with x since I think that's easier, so it's harder to confuse with the plus signs. So we can do some algebra. So we have actually do this the other way. So with some algebra, we can find the new we can update mn with this value. Since we know that, or I guess it'd be the this value plus 1. Since we know that the answer cannot be lower than this value. And then something similar applies for the maximum. So this is rather awkward. My pen just ran out of battery. Here, let me think I can get it to work.
Okay, I see one student keep set the translation to Russian. If you do you need that really? Okay, I'm sorry, it's kind of annoy a lot of students. Please stop it, okay? Stop playing around, okay? This is not fun.
Then we can use something similar here.
It's working, we can see it's writing. What do you mean?
Okay. Yeah, I think my pen died again. Yeah, that's unfortunate. It's fine. Okay, so and then we can end up with the fact that x is less than this value, and we can use it to update mx. There's also a little bit of casework that has to be taken into account to deal with integer rounding to make sure that you round up. And also keep in mind that this final update says that x is less than. So when we update mx as the possible value, we'll update it with this -1. So with some math, we can calculate the exact times at which the mn and mx will be updated, and we can use that to determine the final interval. The total complexity will end up being the total complexity will end up being O of n, since we only have to since there's only n adjacent pairs, and that's all there is for the third problem. Does anyone have any questions? Just keep in mind that my pen is dead now, so I can't help with any drawings or anything. So then if not, I wish I could. My pen is dead though. Yeah, or like yeah, I would run through a sample case if I could. So I think that's it for the problem explanations then.
Okay, thank you, Wei-Ming. Here we have a summary page I just put into a slide, so it's easier for the student to capture. Maybe how about you give the summary here? Yeah, just summary these three problems. Wei-Ming, can you see my screen?
Yeah.
Okay, yeah. Just a quick summary about this problem, the knowledge used, especially the correspondence to the courses in XCamp.
Yeah. Sure. And then the first problem focuses mainly around greedy and math. The second problem is mostly greedy problem, and the third problem is about sortings, not necessarily geometry, but definitely math. And yeah.
Okay, thank you. You can see this corresponding to XCamp 102, 200, 2 classes. So if some of you attend XCamp class, it will help you to solve these problems. Yeah, if not, we are happy, to see if you join our classes. In addition, here we have we try to help each student to analyze your your performance in the this USACO contest. We have a form here. I just typed in the chat. Please click this form and submit your score, so you can receive a kind of evaluation report card like this. So if you want to have, also please join our Discord, so we can have more discussions, especially for the future contest too. Yeah, everyone here, please click the form link, submit your score, so you will get a report card. In addition, please click the Discord link to join our Discord channel. Okay, sounds good. Let's see if I have any questions here. Yeah, please just raise your hand to ask questions. There's annoying kids that can mess up the chat. This is not fun. Okay, please don't do that again.
Wait, do I even have to fill out the form?
If you don't like to, it's okay. If you don't like this report card.
By the way, I am not in XCamp.
Yeah, this is not for XCamp student only. If you are not in XCamp, you are kind of recommended to fill in this kind form so you can get the report card. Yeah.
But do I need to?
No, it's not required. It's recommended.
But does my mom want me to?
That's this between your mom and you. Okay.
You did not tell me.
What? If your mom asks you to do so, if you want to follow her instructions, you would like to follow. If you don't want to, that's kind of your decision. Yeah. We are just here to help you, to try to help by analyze your results and give you some suggestions. Yeah. Okay, any questions for these 3 problems? No? Okay. Also, we have our assistant Alex Du. He's here too. He's also a USACO TA, Platinum Division achiever. So, Alex, do you have any comments? It's good.
No, I think we did a good job covering everything.
Okay. Okay. Great. Last call. Any questions? Any questions?
Oh, for the first problem, I think you can go to the YouTube live stream and wind back a little bit. I covered it there, and it's recorded already.
Yes. Let me share with you the YouTube channel. We have a live stream too. So if you missed, you can go there and check the previous explanations. Yeah.
Okay, so as for the complexity of the third problem, it should run in O of n time, or I guess it's O of n log n time in total, or O of n depending on what you use to sort. It's possible to sort it in O of n time, and it's also possible to sort it in O of n log n time. As for the cutoff isn't announced, and I wouldn't know anything about the official thought process that goes behind making the cutoff. But just my personal opinion, doesn't weigh on the actual cutoff. But I don't think it'll be any higher than 750. But that's just my own thoughts.
Okay, sounds good. Yeah, if you like to send your code, you may send your score and send us email, so we can maybe share the code with you too. In addition, I see a parent student ask, what's the USACO enhancement class in us? For us, we now we call it a markup test. It was originally called the enhancement class. So every week we have a mock test. We have from October. Now from the future ones in January, February, and March, we have a mock test every week, except the USACO contest weekend. We don't have that. So we have 3 every month in the coming 3 months. Yeah, if you are interested, you want to improve your coding skills, you want to pass some levels, please join our enhancement class. Now we call it a markup test class. Yeah. Let me see if there are other questions.
Okay.
One is about the complexity of Q3. I think we may talk about the complexity of question 2, right?
Oh yeah, I mentioned it for the third question as well. It's
Okay.
It should be n log n time or O of n time, depending on what you use to sort. And the final math computation part, you should use O of 1 time for each pair of cows, or O of n time in total for the final portion.
Okay. Let me see if we have other questions here. The naughty boy make it real.
Okay, my
annoying.
mom says I have to join.
Okay. Anyway, I don't want to go through all the tests now. Anyway, any more questions? Yeah.
Oh,
Any
never
more
mind.
questions?
Just Discord.
Okay, yeah, just join our Discord. Yes. Okay. If no more questions, let's stop here. We will, for the future, we have a winter camp. We have 1 week on site in San Jose. If you kind of want to improve your coding in a short of time, please just join our winter camp. It's from December 26th to December 30th. It's 5 days from 9 to 5. Okay, great. Thank you again, Wei-Ming. Also, thank you, Alex Du, for all of your help. I wish you, also all the students, thank you for your time to attend this session. Hope this helps you to understand the problems better. Thank you all. Have a nice holiday season. Have a good night.